Hello. In this section, we will be going over second order differential equations, differential operators. So in this lesson, we will introduce differential operators and see how we can task a differential equation, and we can rewrite another notation. So we can use it to solve homogeneous, complementary equation, and solve it for inhomogeneous differential equations. In this lesson, we will also go over how to turn an inhomogeneous differential equation into a homogeneous differential equation. Then we will go over if you have two equations and how to solve those two equations using annihilation method or the elimination method. So yeah, differential operators, annihilation method. We've done this before. We substitute dy with y prime. So what we're doing is basically replacing y prime with dy, and we're replacing y double prime with d square y, right? We've done this before. Um, so dy over dx is this is not a partial derivative. This is dy, not d lowercase y down here. D, that would be a partial derivative. That's the same thing as dy in respect to x, right? So this thing right here does not equal this. Okay, so let's kind of like practice a bit. If y prime plus 3y prime plus 6y, rewrite using differential operators. Uh, so yeah, I kind of did this a bit. So I replaced y double prime with d square y. That's what I did. And then I replaced three the y plus 3y prime with 3 dy, and I left 6y alone. So this is what I got here. Then what I see I could do is they all both have a common y, so we can just factor that out. And now I have this. Okay? So pretty simple. So all I did was just replace y double prime with d square y and y prime with dy. Nothing new so far. We've done this before. And then factor as much as you can. So let's do another example. If L equals d squared plus 2etd plus square root of t, where y equals t cubed, where y equals t cubed plus cosine t, find L of y. So L of y is going to be, so what can we do here? Oh, so basically what we're doing is multiplying L by y. So L of y is going to be L times y. So it's basically d squared plus 2et d plus square root of t times it by y. Okay, and then if you FOIL out that y, you're going to get d square y plus 2et dy plus square root of t y. Okay, so all I did was I multiplied d with y, and then I FOILed out that y. Now what we're going to do is substitute our d squared and our dy. So if you recall, if if you recall, they tell us that y equals what? D squared t cubed plus cosine t, right? Well, we need d squared and dy. So that's we need basically first derivative y and second derivative y, right? Let's do that. Okay, so wait, you see this d squared y? That's the same thing as y double prime. And then do you see this dy? That's the same thing as y prime. Okay, so if y equals t cubed plus cosine of t, Uh, y prime is going to be 3t squared minus sine of t. And then y double prime is going to be 6t minus cosine of t. Okay, so that means L of y, here, let me put it here, is going to be, so d squared y is the same thing as y double prime, which is 6t minus cosine of t plus 2et, and then you're going to replace dy with y prime, which is 3t squared minus sine of t. And then over here, it's plus square root of t times y, so that's going to be plus square root of t times it by y, which is t cubed plus cosine of t. Okay. So this is L of y. Okay, let's move on to another example. Okay, so this one says, example one, apply the differential operator to the indicated function, d to the fourth, and then y equals 10x cubed minus 2x. So this should have a y. D fourth y is the same thing as fourth derivative. So what we're going to do is multiply uh, y by d4. So we're going to find d or y, and that's going to be d to the fourth. We don't know what d to the fourth is, but we do know what y is, which is 10x cubed minus 2x. And then we just basically take the derivative. So d cubed, and then you just take the derivative of this. What's the derivative of 10x cubed minus 2x? That's 30x squared minus 2. And then what's the derivative? And then keep on going, d squared. What's the derivative of 30x squared minus 2? That's 60x. And then derivative of negative 2, 0. And then what's the derivative of this? One more time, that's 60. And one more time, that would be 0. So that's a total of 4 times. So this would be 0. Let's move on. Example 2 says apply the differential operator to the indicated function. We have parentheses d minus 2 times d plus 5, and we have y equals e to the 2x plus 3e to the negative 5x. So what I would do first is FOIL out this d minus 2 and d plus 5. So if you FOIL that out, it's going to be d squared, and then d times 5 is 5d, and then negative 2 times d is negative 2d, and then negative 2 times 5 is negative 10. If you clean that up, that's going to be d squared. 5d minus 2d is 3d minus 10. And yeah, then what we're going to do is multiply this by y, right? So it's going to be this whole thing by y. And that's going to give you, and then just, we said that y was e to the 2x plus 3e to the negative 5x. Okay, and then what you would do is FOIL this out. I know it is a pain. So when you FOIL this out, you're going to get d squared e to the 2x plus 3d e to the 2x minus 10 e to the 2x. Okay, so what we have is this d squared, it represents second derivative. This 3d e to this 3d represents first derivative. This d squared represents second derivative. This d represents the first. Okay, so what we're going to need is we need to find this. We need to find the first derivative and second derivative, right? So we were given y equals uh, y was e to the 2x, and then dy. Oh, we have two y's, right? Let's make our two y's as y equals 2x, and then our other y was e, the second part of this one. No, it would be e to the negative 5x. Okay, and then we're going to do dy, basically y prime, which is what's the derivative of e to the 2x? 2e to the 2x. And then let's find d square y, or y double prime, which is 4e to the 2x. And then over here, if y equals e to the negative 5x, dy or y prime is negative 5e to the negative 5x. And then d square y is y double prime is the derivative of negative 5e to the negative 5x is 25e to the negative 5x. And then just replace what we have. So d square is 4e to the 2x. And then over here, d is, okay, for this d is y prime, which is 2e to the 2x. And then over here, second derivative was 25e to the negative 5x. And then first derivative is right here, negative 5e to the negative 5e to the negative 5x. So all we're doing is substituting these values, this and this and this, into first and second derivative. That's it. So it's going to be equal to 4e to the 2x plus 3 times and 3d, which is the first derivative, and that is going to be 2e to the 2x minus 10e to the 2x plus 3. Uh, d squared is the same thing as second derivative, which was 25 e to the negative 5x plus 9d. D represents the first derivative, which is uh, negative 5, negative 5e to the negative 5x. And then it's going to be negative 30e. Oh, that's just negative 30e to the negative 5x. Okay, so then you just collect like terms, wait, or kind of clean this up, I guess. So this is 4e to the 2x plus this would be 6e to the 2x minus 10e to the 2x. 3 times 25 is 75. E to the negative 5x. 9 times negative 5 is negative 45. E to the negative 5x minus 30 e to the negative 5x. And if you, they all cancel out. If you collect like terms 4 and 6e, 4e to the 2x and 6e to the 2x is 7, no, 10 e to the 2x, and then you have this negative e to the 2x. And then if you like these two terms, negative 45 and negative 30 is also going to be negative 75 e to the negative 5x. And as you can see, everything cancels, so you're just left with 0. Okay, so let's talk about annihilation method for undetermined coefficient. So annihilation method for undetermined coefficient transform an inhomogeneous differential equation into a homogeneous differential equation by applying a differential operator to both sides. So some of the steps includes step 1, change the differential into one with partial differential operators. Step 2, find the complementary homogeneous solution. Step 3, find an annihilator for GT. Step 4, form the general solution by applying the annihilator to get both sides and getting another homogeneous equation. And also, very important note, remove any function that already appears in the complementary solution from step 2. Okay, step 5 says now proceed. Step 5 says now proceed with the method of undeterminate coefficient for your nearly acquired particular solution. So here's a little bit of review. If you have a polynomial, your annihilator would be d raised to the m plus 1. And yeah, so yeah, if you have a polynomial, it's going to be d raised to the m plus 1. And then if you have like a trig, like a cosine or a sine, it's going to be parentheses d squared plus beta squared raised to the m plus 1. And then if you have an exponential like e to the rt, the annihilator would be d minus r. And if you have an exponential and a trig, so example, if you have e to the alpha t cosine beta t, or an exponential trig, it would turn to this uh, d minus alpha squared plus beta squared. Over here we have, if you have a exponential and a power, it's going to be d minus r to the m plus 1. And then if you have an exponential and a trig, or if you have a power and an exponential and a trig, it would look something like this. Okay, so go ahead and write that down if you need to. Let's do an example to make this all clear. And yeah, if you just have a trig, like a cosine or a sine, it's just going to be d squared plus b squared, a base square. So let's do an example. Example says find a linear differential operator that annulates the given information. So this is just a little bit of review. If you have a power like this, it's going to be d to the n plus 1. If you have an exponential, it's going to be d minus r. If it's a sine or a cosine, it's going to be this. So let's look at the first one. 1 plus 6x minus 2x cubed. What do we know about this? Uh, what is this? This is technically this whole thing, 1 plus 6x minus 2x cubed, that is technically a polynomial. And yeah, so what that means, if you have a polynomial like this, Tm, that's just going to be dm plus 1. So what that means is our highest power was 3. So the highest power is 3, so add 1. So it's just going to be d to the 4th. Okay, what about 2? We have 4 plus 7e raised to the 2x. What do we have? We have two terms. 4 is technically polynomial, right? It's like same thing as 4x to the 0, so this is a polynomial. 7e to the 2x is technically an exponential. So over here, 4 is a polynomial, so that would be d m plus 1. Now 4 is the same thing as 4x to the 0, so our power is 0. So it's going to be, our power is 0, so it's going to be 0 plus 1, so that's going to be d to the 1. And over here we have an exponential. So what do we do when we have exponential? Exponential is d minus r, and our r is technically 2. So it's going to be d minus 2. So we have two terms. We have a d and a d minus 2. So that is just going to be, we multiply those two out. We multiply this by this. And that's what we get. Okay, let's look at 3. We have x to the 1 plus 3x e to the 6x. Let's see here. 1 is x to the 1 is a polynomial. And then 3x, we have 3x times e to that. So it's a polynomial times exponential. So it's going to be tm times e to the rt. So let's start with the x. This is the power of 1. So it's going to be d and then m plus 1. So my m is 1. So 1 plus 1 is 2. What about here? It's just going to be, so if you go to tm e to the rt, we said that that would be, um, it's basically, here, let me, so you have tm e to the rt, it's just basically d minus your power, which is 6, square, right? So when you put it all together, it's going to be d squared times d minus 6 squared. Okay, what about 4? We have 13x minus sine of 5x plus 9x squared. So what do we have? This 13x minus sine 5x is a polynomial. Oh wait, no, no. Let's rewrite this. I think we have a polynomial and a trig, right? Let's rewrite this as 13x plus 9x squared minus sine of 5x. That's much better. And yeah, so this is now a polynomial, and the rule for a polynomial is Tm to the dm plus 1. And then this is a trig. You have a sign, so that's going to be d squared plus b squared. That was part of the rule. So let's do the polynomial. Our highest power was 2, so it's going to be 2 plus 1, which is 3. Plus, over here, this negative sine 5x is going to be d squared plus 5. D squared plus beta squared, our beta is 5. So it's going to be really d squared plus 5 squared. And when you multiply those two out, it's going to be d cubed times d squared plus 5 squared, which is 25. Okay, let's move on. Okay, example, use the annihilation method to find the general solution for this. So we have y prime minus 3y prime minus 4y equals 10e to the 4t. So what we have to do first is write it as so step 1, I would write it as a differential operator. Okay, so y prime is the same thing as d square y minus 3y. That's minus 3y prime is the same thing as negative 3 dy. Minus 4y, so it's just minus 4y, and then 10e to the 4t is just that. Okay, and then on the left side of this equation, what do they all have in common? They both have a y, so you can factor out a y. So that's going to be d squared minus 3d minus 4 equals to 10e to the 14. Okay, then what you would do is solve the homogeneous equation. So step 2. Okay, so step 2, we got to find the homogeneous and complementary solution. What we got to do is find the YH, and we got to set it as a set it as a homogeneous. So how do we set it as a homogeneous? We set the right side to 0. So basically, you could ignore this y because if you set the right side to 0, it cancels anyway. So really, it's just going to be d squared minus 3d minus 4 equals to 0, right? So basically, I set the right side to 0, And I got rid of this y by dividing both sides by y. Okay, now go ahead and solve for your d. So factor this out. Factor it out nicely. What two numbers multiply -4 when added gives you -3? It would be -4 plus 1. And you get d equals 4, and then d equals to -1. And these are your distinct real roots. So your y of home, your y of h, is going to be C1e raised to the, so one of our d is 4, so it's going to be 4t plus C2e, and then one of my d is -1, so that's -t. Okay, then step 3, find AT, find the n, find AT or the annihilator, find AT that annihilates GT. So step 3, find AT and annihilates GT. Okay, so we know that GT is the right side, or our GT is 10e to the 14. So my GT is 10e to the 14. And we know this is an exponential function. And then our AT is d minus r, because it is an exponential. So it's going to be d minus r, and then r was r is 4. Power is 4, so it's going to be d minus 4. Okay, step 4, multiply both sides by d minus 4. So multiply both sides by d minus 4 from step 1. Okay, so on the left side, from step 1, what did we have? We had d minus 4, d plus 1, and then on the right, we had 10e to the 14th, right? So on the left side, it was d minus 4 times uh, d plus 1. And then on the, whoops, yeah. And then on the right, we had 10e to the 14th. And then we just got to multiply both sides by d minus 4. So you can multiply this by d minus 4. And then this is going to be d minus 4. Okay. Apply the differential operator to let 10e to the 4t annihilate it or cancel it. So applying the differential operator to 10e to the 4t annihilate or cancel it. Okay, so basically you set the right to 0. So it's going to be d minus 4 times d minus 4 times d plus 1 equals 0. So now this is a homogeneous. So when you actually solve for your d is going to be 4, 4, and -1. You have a repeated root at 4. So your y is going to be c1e to the 4t plus c2. So if remember, if you have a repeated root, I believe you have to multiply it by t. So it's going to be c2t e to the 4t, and then it's going to be plus c3 e to the -t. Okay, does this right here, so you tell me, does this look anything like from YH? Um, where's YH? Um, I don't think so. So what we could do is step 6. Oh, wait, actually, yes, it does. The C2, the C2E2, e to the 4t does look like from YH. Yes, right here. Uh, so it's a guess from the particular solution. So you're going to say, oh, so yes, it does. So it's going to be C1 e to the 4t goes to C1 e to the 4t. So this right here does look like from YH. So, and then so does the C3. So the C3 e to the -t is going to be C2 e to the -t. Okay, so step 5, take the appropriate derivative and plug it into the differential equation. So our YP is going to be A T e to the 4t. So what you're going to do is now take appropriate plug it into differential equation. Okay, so what is our YP prime? Is taking the derivative of this. So what do we have to do? This you would have to apply the product rule. This is like two terms multiplying each other. So to apply the product rule, so it's going to be A T, and then take the derivative G prime, which is 4e to the 4t plus e to the 4t times the derivative of f. So this is your f, this is your g. The derivative of at is a. Okay, and then if you clean that up a bit, that's going to be 4a t e to the 4t plus a e to the 4t. And then you take y double prime, which is Going to apply the product rule again. So it's going to be 4AT times 4e to the 4t plus e to the 4t times 4a plus 4a e to the 4t. If you clean that up a bit, you're going to get 16a t e to the 4t plus a 8 e to the 4t. So next, we're going to plug this back into your original equation. So we're going to plug this. So our y p double prime this derivative into this. So we have our y double prime and our y prime. We just plug it back in here. So it's going to be y double prime is going to be 16a t e to the 4t plus 8a e to the 4t minus 3 times y prime is 4a t e to the 4t plus a e to the 4t minus 4, and then our y was just regular y was at e to the 4t equals to 10 e to the 4t. Okay, clean it up and use the comparison method to figure out what a equals. So clean it up. Use the comparison method. What a equals. Okay, so we clean this up a bit, FOIL it out. The left side is going to give you 16 a t e to the 4t plus 8 a e to the 4t minus 12 a t e to the 4t minus 3 a e to the 4t minus 4 a t e to the 4t equals to 10 e to the 4t. And then all you got to do is combine like terms. So when you combine like terms, you get 5a e to the 4t equals to 10 e to the 4t. But if you collect the left side, you're going to get 5a 5a e to the 4t and then solve for a. So you would have to, I guess you can divide both sides by e to the 4t. So this cancels, and then you're left with 5a equals to 10. And then solve for a. A equals 10 divided by 5 is 2. Okay, so our general solution is going to be is y equals y of h plus yp. So our y home is c1 e to the 4t plus c2 e to the negative t. And then our yp is 2t e to the 4t. Okay, so that was solving using annihilator method. Now, we can also use differential operators by elimination. So you kind of done elimination before on your algebra course. So how do you use differential operators to solve using system of elimination? So step one, rewrite both sides using differential operators. Step two, eliminate the x term and find a solution for y. Step three, eliminate the y terms and find a solution for x. So you're solving for x then y by multiplying both sides by a number. Step four, rectify the arbitrary constant so you can have C1 and C2. And then step five, write your solution. So a little bit of review of elimination from algebra. Let's say you had 2x minus y equals 9, and then 3x plus 4 equals negative 14. So just a little bit of review. How would you solve for x and y? You would do elimination, and I would multiply the entire equation 1. So if I want to get rid of the y's, I would have to multiply the entire equation 1 by 4, right? If we have if we want to get rid of the y, we have negative y and 4y. What I do is think of a common denominator between negative y and positive 4y, which is 4y, right? And you just have to make one positive 4y and the other one negative 4y. So I made this negative y into a negative 4y. How did I do that? By multiplying this side by 4. And when you FOIL this out, this is going to be 8x minus 4y equals to 9. And then this stays the same. And then add them up. So this would be 11x. And then the y's cancels. And then 9 plus negative 14 is, I didn't multiply the last by, always multiply the last term by everything by 4. So this should be 36. So 36 and negative 14 is 22. So x is going to be 2. And then how do you find the y? You simply plug in x into one of the original equations. So you could plug it back here or here. Do not plug it in here because that's not an original. If I do that, that would be 3. I'm going to put it right here. So I'm going to multiply that where we see next, plug in 2. So 3 times 2 is 6 plus 4y equals negative 14. And then solve for y. So you're going to subtract 6. Negative 14 and negative 6 is negative 20. Divide this by 4. and I get y equals -5. Okay, so let's do an example where we have to do solve using the elimination. So these ones are going to take a bit more time, and we're going to do them very carefully because there is a lot of algebra we have to do. So we'll do this carefully, step by step. Okay, so let's start with example this one. So this one says solve the system using elimination. And we have dx over dt equals to -y plus 6, and then dy over dt equals to x minus 6. So step one, rewrite both equations using differential operators. Okay, so dx over dt is the same thing as dx. Uh, wait, so yeah, so dx is the same thing as -y plus t. Yeah, I think this just should be a t, not a 6. Sorry. And then you would do is solve for t. So you would it's going to be dx plus y equals to t. And then over here we have oops, dy equals to x minus t. Why is this 6? This should be a t. So it's going to be x minus t. And then what you're going to do is kind of get negative t by itself. So you would have to subtract x. You get dy minus x equals to negative t. Okay, so we did this so we can set up a system of equations. So dx. So we're going to set up a system equation. So it's dx plus y equals to t, and then this is going to be dy minus x equals to negative t. Uh, can we set up our system equation? Yes or no? Not quite. Why can't we set it up? Because we have to line up the letters. This has an x, this has a y, this is a y, this is a x. So we kind of have to like kind of move it around. So let's rewrite it as dx plus y equals to t, and then this is going to be dy. Oops, I meant it would be, sorry. We're going to set up as dx Okay, so all I did was I just moved this negative x in front. You can do that, right? That doesn't change the problem. And yeah, so now let's do elimination. So we can get rid of the, what do you want to get rid of? We can get rid of the dx by multiplying the second equation by d. So yes, get rid of dx. Second by d. So yeah, multiply the second equation by d. I'm going to rewrite the first equation again, and then I'm just going to FOIL out this d. So this is going to be negative dx plus d squared y equals to negative dt. So if you add them up vertically, dx and negative dx cancels. Y plus d squared y is, you can't combine them, right? This is second derivative. So it's just going to be d squared y plus y equals to uh, t minus dt. And what I would do next is on the t minus dt, I would take the first derivative. So what's the derivative of t minus dt? Or I take the derivative of dt, which is -1, so this is going to be t minus 1. And then over here, d squared y plus y, you can take out a y. That's going to be d squared plus 1. And then what you could do is set each equation to 0. So you could set d squared plus 1 to 0. So now you have d squared plus 1 equals to 0. And then if you solve for d, you're going to get plus or minus I, which is 0 plus or minus I. And 0 is your alpha, and then your I is your beta. So your y of h is going to be c1 e to the 0 times cosine of t plus c2 e to the 0 sine of t. So your final equation, your final y equation is going to be your y of h plus your yp, which is c1 cosine of t plus c2 sine of t plus your yp. Our yp is, what is our yp? It is, I didn't find it. Yp is d squared times d squared plus 1 equals to t minus 1 d squared. So our d is going to be 0 and 0 plus or minus I. So your final answer is y equals to c1 cosine t plus c2 sine t plus t minus 1. Okay, so t minus 1 is your yp. Now we got to do the same process to solve for x because we're not quite done. So step 3, do the same process to solve for x. So we had, what was our system equation? It was dx plus y equals to t, and then we had negative x plus dy equals to negative t. So what I would do is multiply top equation by d and multiply the second equation by negative 1. That will somehow get rid of your y's because we want to solve for x. So multiply top equation by d. So multiply the top equation by d and multiply second equation by negative 1. So first equation is d, and then second equation is negative 1. So that's going to be d squared x plus dy equals to dt. And then on the right, on the bottom, it's going to be x minus dy equals to t. So when you put it all, when you add them up vertically, you're going to get d squared x plus x equals to dt plus t. And then on the left side, you could take out 1x. So this would be x times d squared plus 1 equals to 1 plus t. Okay, then you're going to set it as a homogeneous. So set d squared plus 1 equals to 0. And when you solve for d, you're going to get you're going to get imaginary roots. You're going to get plus or minus I. Okay, now, so what we're doing is finding the equation for x. We just found the equation for y, so let's find our x home, xh, which is c3e to the 0t of cosine of t plus c4e to the 0t of sine of t. So that's good. So our final equation for x is your xh plus your xp. So it's going to be x equals c cubed cosine of t plus c4 sine of t plus your x of p, which is 1 plus t. Okay, so that is your equation for x. Is this our final answer? So now we've got to take both. So now we've got to take both of our solution and plug them into the original and simplify to solve for your C3 and your C4. So now, let me write this out. Now you take both of our equation So now we take both of our equation and plug them into one of the original simplify to solve for C3 and C4. So step 4 is we're basically going to rectify the constraints by plugging into one of the original differential equations and solving for C3 and C4 in terms of C1, C2. So rectify constraints. To okay, so what we had, so in step 4, we had dy over dt equals to x minus t. And we said y prime, this was given. This is our original equation, y prime equals x minus t. So dy dt is the same thing as y prime. And if y equals c1 cosine of t plus c2 sine of t plus t minus 1, then we must find y prime. So the derivative of this is negative c1 sine of t. And then the derivative of this is plus c2 cosine of t. And then the derivative of t is 1, and then the derivative of negative 1 is 0. So then what we do is we just put it here. We know our y prime, which is this, set it to x minus t. So you're going to set it up as negative c1 sine of t plus c2 cosine of t plus 1 equals to x minus t. And what now, see here, what is x? X was, we just solved that x is c3, we're going to plug that x, c3 cosine t plus c4 sin t plus 1 plus c is, so x is c3 cosine of t plus c4 sine of t plus 1 plus t minus t. And our t is going to be, wait, so, and then over here we have negative c1. And then just, what can we do here? Oh, this, do you see this t's cancels? Because positive, negative t. So now on the right side, you're left with c3 cosine t plus c4 sine t. And then over here, you're left with negative c1 sine t plus c2 cosine t. Oh, wait. So, and then you also had this extra one. So did you know these ones cancels? So now what I'm trying to do is get one side 0. So let's move everything to the left. Move this c3 cosine of t minus c4 sine of t. So you get negative C1 and what we do here, we could factor out, you just combine like terms. So let's start with our C. So we have a negative C1t, negative C4ct. So that's going to be negative C1 minus C4 of sine of t plus, and then what about your cosine t? You have C2 cosine t negative 6 negative C3 cosine t. So that's going to be C2 minus C3 of cosine of t equals to 0. So then you're going to set this, set each equation to 0. So set this to 0 and set this to 0. So you get negative C1, negative C4 of sine of t equals to 0. And then the other one is C2 minus C3 cosine of t equals to 0. And then I could get rid of this sin of t if you like, divide both sides by sin of t. This cancels, so now you're left with negative C1 minus C4 equals 0. And then if you got solve for C4, you're going to get C4 equals negative C1. Same thing here, you would have to, you can get rid of this cosine of t by dividing both sides by cosine of t. And you get C2 minus C3 equals to 0. And now you have C3 equals to C2. Okay, step 5. Uh, you found your C1, you found your C4, you found your C3. So your final answer is going to, so your final equation for your final equation for your y is going to be E1 cosine of t plus C2 sine of t plus t minus 1, and then x equals C2 cosine of t minus C1 sine t plus 1 plus t. Okay, so this is your final equation. Okay, I think that is it. Yeah, so that is the elimination method. It's a long process. Um, so yeah, I'm gonna stop here.